Good morning. And thank you very much for giving us this opportunity to come and speak to you about some of the research I've been doing at Kansas State University. We apologize for the delay. We never thought that it's going to take about 3.5 to 4 hours to get from Manila to here. We started around 6:30. Because of the last night rain, I think the traffic was too much. And so anyway, we are here. So I'm really glad to be here and have this opportunity to talk to all of you. So my title of my presentation is going to be Global Challenges and Local Solutions, Sustainable Intensification for Food and Nutritional Security. Before I go into the seminar, I just wanted to show you where Kansas is. This is a US map, and then Kansas is right in the middle of US. And within Kansas, Manhattan is over here. Manhattan is a small town. It's not the big apple of New York. It is Little Apple of Kansas. That's what we call it. And we have Kansas has a population of about 2.9 million. And economy is primarily based on agriculture. And we have about 28 million acres of cropland, and 2.76 million acres is irrigated. And Kansas State University is one of the first land-grant university formed in US, and we have a total student population of about 23,000, and population of Manhattan is about 50, so half of it is students. And in terms of ranking, Kansas ranks number 1 in the total production of wheat in the US, and also we are number 1 in the total production of sorghum in US. About 60% of the US sorghum is produced in Kansas. And as I said before, it's the first land-grant university established in 1863, and the College of Agriculture ranks number 4 in the US. So this is some of the outline of my presentation. First we'll talk about global challenges, which includes hunger, malnutrition, and climate change. And then we'll talk about some of the opportunities. We'll go through what the current yield gaps are, what are the input use, and then the food loss and food waste across the globe. And then I'll introduce you to the topic of sustainable intensification, the meaning of it, and what are the various components of sustainable intensification are. And then I'll introduce you our innovation lab, Feed the Future Sustainable Intensification Innovation Lab. I'll give you an overview of that, and then some specific examples of local solution to the grand challenges in the countries where we are working on, and I'll conclude, and hopefully there will be time for questions. So first is global challenges: hunger, malnutrition, climate change, soil fertility, and the grand challenge for current generation of scholars. So this is a global map of undernourished population. If you look at globally, in sub-Saharan Africa, about more than 30% of the population is malnourished or undernourished, and about 120 million people do not get enough food to eat. And in particularly Asia and Africa, more than 20% of the population, if you count all of these, is undernourished. At the same time, obesity is also a big issue, but not in the same countries. Here's a global map of percentage of adults 18 plus obese with a body mass index of more than 30. This is the 2016 map, and it is widespread. About more than 30%. Most of it is in America, and then some of it is in North Africa and other regions of the world. But 30% of the population is malnourished in sub-Saharan Africa, and 30% of the population is also overnourished or obese around the globe. So we have dual issues with food consumption. And then this is anemia. This is the percentage of children under 5 years who are anemic. Again, a lot of the sub-Saharan Africa and African continent and South Asia are anemic. Iron deficiency. Anemia is iron deficiency, and especially it is seen in women and children. And more than 30% of Africa and South Asia are anemic. And some of the other micronutrient deficiencies include zinc deficiency and also vitamin A deficiency. So nutritional needs are critical. And now moving on to the soil degradation. This is the global map of soil degradation. There's plenty of soils around the world which are very degraded, and very little of them is stable. So especially in this part of the region, sub-Saharan Africa, there's a lot of the soil degradation is happening, and that needs to be addressed to address the global food production. And if you look at what's happening in terms of the yield trends across the globe, on the top here on the left of you, this is the years, and these are the yellow line is the world population growth. It has been declining since 1980s onwards, but at the same time, this purple or the pink line is the average corn, wheat and rice yield growth. This is per annum. So as you can see, the declining in the rate of yield gains is declining faster than the rate of the population growth. And then if you look at these bars here, the blue and the green bars, these are for the 4 different crops, wheat, rice, maize and soybean, and that's a decadal improvement in the yields. So if you look at the blue line is 1965 to 1999, and the green line is from 2000 to 2008. And its axis is a percentage of yield increase for these crops. It's been declining. In 60 to 2009, the wheat was around 2%, and then the rice was close to 2% as well, maize was the same, and soybean was about 1.5, but now we have decreased to less than 1% for most of the crops, with an exception for maize, which has stayed the same from 1965 to 1999 and 2000 to 2008. And that's probably the reflection of the private sector engagement in the hybrids and the management of corn or wheat. And with the growing population, it is projected by 2050 there will be about 9.2 billion people, and we really need to double our productivity in terms of the rate gains. This particular paper says that for major grain crops, maize, rice, wheat and soybean, we have to increase it by about annual gains have to be about 2.4%. And right now we are at about 1%. So there's a significant need to increase these rates of yield gain, and we have to achieve that under the conditions of climate which are changing rapidly. And this is a global temperature. The baseline is as an average of 1951 to 1980, and then this is a temperature anomaly compared to that. And as you can see, most of the recent years from 1960 onwards, the global temperatures anomaly has been increasing. And I think for the first time in 2016 or 17, we hit that 1 degree Celsius rise from an average of 1951 to 1980. That's the first time we actually, global surface temperature are more than 1 degree Celsius warmer. And then most of the warmest years have happened in the last 2 decades. If you were to count the hottest years in most of the regions of the world, most of them have happened in the last 15 to 20 years. And not only the temperatures, but the water stress is going to be the key for future. And this is the areas where there's going to be tremendous amount of water stress. And the stress is coming not only from the increased population, but also the variability in the climate as well. So if you account into the population growth and the demand for water for agriculture and other activities, especially India and Southeast Asia is going to be tremendously under water stress. So that's the current status. And then as I said before, the global population is going to increase from 7.3 billion right now to about 9.2 billion by 2050. But majority of that population increase is going to happen in Africa. So if you look at 2015, Africa is right now at about 1.2 billion, and by 2050 it will be 2.5 billion. Pretty much every major country in Africa is going to double its population. And as I mentioned before, at the current levels of population, about 30% of the population is undernourished. So it's going to have significant challenges for production of food. So the global challenge is that how do we increase the production without damaging our environment? It's projected globally we need to increase the production by 60%, and in some cases of the developing countries we'll have to double it. And we have to do it under the current environmental and the soil conditions. Our soils are already in the pressure of intensification, and we really need to overcome and address those issues. That's a grand challenge for this generation. So now what are the opportunities? We have seen the challenges, and what are the opportunities? And this graph here, or this map here, shows the crop productivity across the world as represented as a yield gap. I hope you all understand what the yield gap means. This yield gap is, in this particular case, is defined as the difference between the attainable yield and the actual yield. I'm talking about the attainable yield, not the genetic potential of the yield, because genetic potential is going to be much higher. By attainable yield, meaning that some farmer in that region, when he used the best management practices, he matched his genotype with environment by management, he was able to produce that much yield. That means it's possible under his or her biophysical and socioeconomic conditions. For example, if the attainable yield is 6 tons, and then actual yield is 4 tons, the yield gap is 2 tons. So that's how it is. So if you look at the map, less than 30% of the attainable yields in Africa. So there's a large yield gap between the attainable yield and the actual yield. So there is opportunity to improve those yields in some of those cases, especially in Africa. And this map is interesting, this graph is interesting to see. This is the input use, particularly fertilizer and nutrients. And then the blue bar is 1962, green is 1982, and the yellow is 2002. And these are just focus on Sub-Saharan Africa, the second bar from the top, and then the South Asia, which is the bottommost one. So if you look at 1962, the amount of fertilizer or the nutrient use in South Asia and Sub-Saharan Africa was very low, less than 5 kilograms per hectare. And then, but if you look at 2002, in South Asia, that increased from about less than 5 kilograms per hectare to almost close to 100 kilograms per hectare. In the same time frame, in Sub-Saharan Africa, it's just gone from less than 2 kilograms per hectare to less than 10 kilograms per hectare. So the input use, especially the nutrients, whether it comes from inorganic or organic fertilizer, has been very low in those regions where the yield gap is very high in Sub-Saharan Africa. And that this graph was up to 2002, and the trend from 2002 up until 2017 is also not so much different. They've improved from about 10 kilograms to right now about close to 15 kilograms per hectare. So there is a tremendous opportunity to efficiently use and provide the inputs which is necessary to improve the yields in those regions. I'm just not talking about inorganic fertilizer. It has to be a combination of inorganic and organic sources of fertilizers. And this is the improved seed. And on the same note, the South Asia, in 1980, about 40 to 45% of the land area, especially this is probably specifically for grain crops, was under the improved varieties. And then 2000, close to 75% of the land area of the cereals was covered under improved varieties. But in Sub-Saharan Africa, it was less than 5, and right now about 25% is under the improved varieties. Again, so there is a huge opportunity there to bring more land into more area under improved seed production. And the final challenge is the food loss and food waste. These numbers are staggering, right? 30%, 45%, 20%, 30 and 20%. This is the amount of food which is either lost or wasted around the globe. About 30%. Comes to about 1.3 billion tons of food worth $1 trillion. So those amounts are huge, right? So I told that we have to improve the production by 60%. Right there is your 30% which could be saved. And then this 30% is the same around the globe, meaning that developed countries and developing countries are contributing to the same 30%. It's the same. In both regions is 30%. But where that loss happens is different. In developing countries, it's a food loss, meaning that most of the losses are happening at the time of harvest, during the harvesting time, storage, and then before processing. Whereas in the developed countries, it's happening after the harvest, during the processing, packaging, and on your dinner table. The amount of food which we waste on our dinner table and in the refrigerators is equally important. So both developed and developing countries contribute to the same amount of when it comes to food loss and food waste. So those are the challenges and some of the opportunities where we can really improve our food production systems. Those are global challenges, and there are local solutions. So I'm going to introduce you now to the sustainable intensification and give you some selected examples of what we are doing in our innovation lab. So the concept of sustainable intensification is increasing food production from the existing farmland while minimizing the negative impacts on environment and natural resources. So the idea is not to bring more land into agriculture, but use the existing land more efficiently. And then it's about total food production per unit area per unit time. So we need to be producing more number of crops per unit area per unit time. And then produce more from less, more efficiently. So those are the principles, concepts of sustainable intensification. The combination of the word sustainability and intensification means that both yield increase and environmental sustainability can be achieved simultaneously. So the goal is to achieve those two simultaneously. It's not that we have to do one after the other, or they can go along with each other. The idea is to do both. And how do we achieve sustainable intensification? There is several ways we can do it. I'm just going to highlight some of the important ones. Improving resource use efficiency, primarily all inputs, water, nutrient, and labor. And then diversification of the farming systems. Example, animal husbandry, home gardens, horticulture, agroforestry systems. These systems also will improve the climate resiliency and nutrition. And it's just not only the biophysical sciences is important, but also social science or socioeconomics is equally important. We need to be creating enabling environment so that the farmers produce enough and they have access to markets, and the social networks are there to continue that production gains, and also ensuring that the government policies are there, especially subsidies and land inputs, so that we are able to achieve that production. And our key thing is to provide options or multiple portfolios to the producers so that they can make appropriate choices to minimize the risk, increase the income, enhance the resilience and the livelihoods of the people. Again, as I said, it's not only related to production but also consumption practices, having access to diversified diets, alternate and efficient sources of protein, which is critical. We really need to address that, although it's tough, but we need to do that. And again, reducing waste during production, transport, processing, storage, and our dinner table is going to be critical. So these are some of the ways we can achieve sustainable intensification. And there are three different components to sustainable intensification. On your right is the box in the red is genetic intensification. And then the green one is the ecological intensification, and the blue one is socioeconomic intensification. So what do I mean by genetic intensification? It's about improving the yield and then breaking the yield barrier and making the crop varieties more resilient to pests and diseases, making them more resilient to abiotic stresses, especially temperature, water, and salts, and also focusing on improving the nutritional and medicinal value of the crops. As I mentioned before, nutrition is also very important or key. And in terms of ecological intensification, it's about the cropping systems and the farming systems, improving soil and water management, integrated nutrient management, diversified farming systems, efficient use of inputs, and integrated pest management. Those are some of the examples which fall under the category of ecological intensification. And the third one is socioeconomic intensification, which is associated with developing markets, building the social capital, and creating sustainable livelihoods, understanding the barriers of adoption, and creating enabling environment for success of the package of practices which are developed. And it's not that it has to be, one has to be done before another. It's not a stepwise process. All three things should be happening simultaneously. We need to ensure that there is enough market for the genotypes which we are producing. At the same time, we have to develop the best management practices for those genotypes to make sure they're managed well and they are put in the right environment as well. So those are the three components of sustainable intensification. Our lab is more focused on the ecological intensification piece of these components. So this is, our lab is called Sustainable Intensification Innovation Lab, or Feed the Future Innovation Lab for Sustainable Intensification. This is a program funded by U.S. Agency for International Development, USAID, under the program of Feed the Future. And in U.S. there are about 24 innovation labs, and this is one of the 24 innovation labs, and management entity is Kansas State University. And Kansas State University has 300 innovation labs in addition to sustainable intensification. We have one on sorghum and millet innovation, and then we have one on post-harvest loss, and the fourth one is wheat genomics. So of the 24 innovation labs, Kansas State University is a home for 4 of those innovation labs. So a little bit details about what our innovation lab is focused and where we are working. We are currently working in 6 countries. In West Africa, we are in Senegal and Burkina Faso. In East Africa, we are in Ethiopia and Tanzania. And in Asia, we are in Bangladesh and Cambodia. And we have a small program in Malawi as well, but we have been focused on this 6 countries for the past 4.5 years. So sometimes I get this question very often, that when we talk about intensification and sustainable intensification, are we talking about large farms or aggregation of land or big farmers? That's not correct. We are mostly focused on smallholder farmers, and these are the reasons why we are focused on smallholder farmers. 1/3 of the world's 7.4 billion people are involved in smallholder agriculture. Globally, about 70% of the smallholders farmers are smallholders with a land area of less than 1 hectare. And smallholders and the family farms produce 70% of our food. And in some cases, or some countries in Asia and Africa, it's actually more than 80% of the food comes from the smallholder farmers. So smallholders are key for sustainable food systems. But unfortunately, in these regions, especially in Africa and Asia, more than 50% of these smallholders are food insecure or undernourished themselves. So it's critical that we work with these smallholder farmers and ensure that there is a transformation in their agricultural practices for global food and nutritional security. So smallholder farmers are key for food security and nutritional security. So this is the structure of our lab. We have a very large and multidisciplinary portfolio. I'm just going to go through just the highlights of what the major components are. And if any one of you is interested to learn more about it, at the end of the presentation there will be a website, and most of the information is available on the website to get you into the more details. So I'll start off with the different types of consortium we are engaged, because nowadays I think the funding agencies are very much interested in funding large consortium or large multidisciplinary teams rather than individual PI or individual commodity-based research. So we have about 4 different consortiums, but 2 of them have been running for almost 4 years now, and the remaining 2 are very new. One of the consortiums which were there at the beginning of our program was Geospatial and Farming Systems Consortium. That was a grant from Kansas State University to the University of California in Davis. UC Davis is the lead of that consortium. And the role of that consortium was to help us identify the regions in those 6 countries where are the opportunities for intensification and what should be the focus of those research projects in that area, and also tracking our progress as we go along during our 5-year period. So that's a Geospatial and Farming Systems Consortium led by UC Davis. And the second consortium was Appropriate Scale Mechanization Consortium. We all know that labor is becoming expensive or unavailable even in developing countries, specifically with the demand from the urban areas. So we have to make sure that we have access to appropriate scale mechanization, meaning that mechanization tools which can be utilized by smallholder farmers. And this consortium is led by University of Illinois at Urbana-Champaign, and they are developing small tools and also machinery which can be used by smallholder farmers all the way from land preparation up to harvesting and threshing. We are not going into the processing and food storage. There are other innovation labs which are focused on that area, but this consortium is working all the way from land preparation to harvesting and threshing. So they are working with 4 different U.S. universities. And then more recently, we launched we are part of the Soils Consortium, which is led by International Fertilizer Development Center, IFDC. We are part of that. And then we also created are part of the Policy Research Consortium at Rutgers University. So those are our 4 different consortiums where 2 of them we have been running for 4 years now, and the remaining 2 are very new. And then in addition to that, we have each country, each of those 6 countries, we have a large multidisciplinary research project which is focused on the topic which was identified by the local scientists and the local farmers in that countries, especially by the National Agricultural Research and Extension Services. And then measuring sustainable intensification is a complex thing. We can measure intensification and sometimes we can measure sustainability, but when you put those 2 together, it's a complex thing. So we also developed a sustainable intensification assessment framework which is available in our website. So that's overall portfolio innovation lab. And totally we engage about 120 scientists, and we have directly or indirectly funded about 107 students from 68 different global and national organizations, including 18 US universities and 7 CGIAR centers. Our Bangladesh program is actually co-led by Kansas State University and the National Rice Research Institute, which is located here. So, how much land area is under sustainable intensification? This was a paper which was recently published, 2018, led by Jules Brady. And what they estimated is that the criteria to be included in this was the practice, sustainable intensification practice, has to be in 10,000 adopted by or being used by 10,000 farmers or in 10,000 hectares. So that was the criteria to be included in this assessment. So it is estimated that 163 million farms, about 29% of the worldwide, are practicing some form of sustainable intensification practices on 453 million hectares of agricultural land. So that's 9% of the worldwide total. So there's still a lot of opportunities to improve. We have 9%, but we have a lot more land which can be brought in with sustainable intensification practices. I'm going to skip that. And now I'm going to give you some examples of how we are working in these 6 different countries and specific things about which will fall under the 3 components of sustainable intensification. Either it may be genetic, it may be agroecological or socioeconomic conditions. And our West Africa program is focused on crop livestock integration, because in these systems, the West African countries, the crop production and livestock are the key, and often there is a conflict between the herders and the crop producers. And when we were having these facilitated discussions with the researchers and a farmer organization in that regions, they identified that crop livestock integration was the key area which needs to be addressed. And within that, our program is focused on dual purpose crops, meaning that the dual purpose, meaning that the grain is used for human consumption and then the biomass is used for the livestock. And we are also interested in the varieties which have high nutrient density in the grain and also in the biomass. So this program in Senegal and Burkina Faso is in collaboration with International Livestock Research Institute, which is leading the Burkina project, and then the National Agricultural Research Organization, INRA, is collaborating with them. And same thing in Senegal. The project is led by Kansas State University, but there is a strong collaboration between ISRA, Senegalese Research Institute of Agriculture there. And these are the 3 crops which were dual-purpose crops which we are working on: sorghum, millet, and cowpea. Sorghum and cowpea is in Burkina Faso, and millet is in Senegal. And then so what we have observed is that so the dual-purpose crops, if you have good agronomy, the planting dates and the planting densities, they are able to produce more yield, and also when you feed that to the cattle, the productivity gains in terms of the meat weight and also in terms of the milk production was higher. So that's why we are focused on. Sometimes the farmers actually make more money selling forages than the grain, especially in the off season. So there's been some good results which we are getting on these dual-purpose crops in this region. And then water harvesting water is a key issue in this region, especially when the rainfall comes in. It either comes in very high intensities, and there is a prolonged drought between the two events of the rain. So we really have to identify practices which can capture these rainwater more efficiently. And then one of the ways which we have done our research in Ghana, Burkina, Mali, Niger, Tanzania, and Malawi has shown that the concept of tide ridges. So the concept of tide ridges is that this is a typical ridges. You have the ridges and they're tied at the end. I hope you are able to see the picture. These are the different crops. This is maize, and these are the ridges. And then we close that ridges, we tie those ridges so that there is more time for percolation for water in the soil. So that improves the soil water because of the more amount of time the rain has to percolate. And our results have shown anywhere 50% yield increase for majority of the grain crops. And so that's just one way of how we are working on. And this is in collaboration with Africa Rising Project, and the Ghana work is with SARI, Savannah Agricultural Research Institute. And another similar concept of water conservation is contour ridging. So these are ridges made considering the slope of the land. So the ridges are contoured, and then again the concept is the same, that you are minimizing the soil erosion and also enhancing the time for water to percolate so that there is more water going into the soil. And then our results have shown about 50 to 100% yield increases for sorghum, millet, maize, and cowpeas. Again, very simple technologies, but huge impact on the productivity. And the Mali work, this one was done in collaboration with IER. which is a national research center in Mali. And then coming now to the East African region, we are focused on integrating legumes in the farming systems. So most of the time there is a cereal, and then we are trying to include a legume either in the rotation or as an intercropping in those systems. And then our project in East Africa, especially Tanzania, is led by Michigan State University, so in the SNAP, and also we collaborate with Africa Rising. So here is a nice concept of doubled up legumes, where you have pigeon peas, groundnuts, or cowpea. So these are the tall ones here are the pigeon peas, and then these are the groundnuts, and these is maize and beans intercropping. So doubled up legume, you can get a perennial legume, which is pigeon pea is a perennial, and then you have an annual legume in combination with the maize system. So that's another way of intensifying, but also diversifying your farming system to ensure that you have a protein source for women and children. And this particular integration of legumes and then double up legumes has shown that we increase the plant efficiency for fertilizer use, and it also decreases the labor requirement because the weeds are better controlled, and also it provides diversity of diet to the family, so that helps with the nutrition as well. And in Ethiopia, we are focused on home vegetable gardens, and this is the project led by Texas A&M, Neville Clark, and then Small Scale Irrigation Innovation Lab is part of it, and Manny Reyes, who's sitting here, is also is a co-PI on that project. In this one, what they are doing is they're growing indigenous vegetables, and under the Conservation Act principles. So they use locally available mulch to cover the soil to minimize the evaporation, and then they are also fitted with a drip irrigation system, which could be a gravity fed or solar powered water lifting technologies. They lift the water using solar pumps, and then it is stored in a tank, and then from the tank the gravity feed will supply water through drip irrigation systems to these commercially home vegetable gardens, and that's been very successful, and we have seen significant yield improvements all the way anywhere from 50 to 200% increase in some vegetables. So that's another way we can improve the yields and make sure the water is being used efficiently. And our Bangladesh program is led by Kansas State University and International Rice Research Institute, which is just next door to you. And then in this one, we are working in the southern coastal zone of Bangladesh, where water management is the key. We are focused on community water management because these are polders, and the water, the sluice gates which control the inlet of the water and outlet of the water is one. So when you are talking about water management, it has to be community water management. Single farmer cannot control the water, because if one farmer is not tying, then the entire area will be affected. So it has to be community-led water management. So we are working on that. And then there is tremendous amount of availability of the water, but it's all saline water, so it cannot be used for farming. So in the summer season, there is a lack of greenery and lack of forages for the livestock. And so in this region, what we are focused on is rice production, and we are focusing especially on a high zinc rice. This is a natural selection done by the Bangladesh Rice Research Institute. It is not a GMO. It is a natural selection of the lines which has high zinc in the grain. So again, as I said before, zinc deficiency is another critical area which is needed. So these are the yields of some of these high yielding high yielding and high zinc lines are very good, and the crop duration is shorter. So if you have a high yielding rice which is shorter duration, there is opportunity to introduce a new crop in the fallow. So we are trying some salinity tolerant crops like sunflower and sesame and some indigenous vegetables in the rice fallows. But the biggest constraint is that you have to have a shorter duration of rice variety which can yield more. So they are working on this type of systems. And when we are looking at rice fish systems in a community-based water management as well. So that's critical in that region. I mean, rice fish is not new, but doing it communally rather than in individual farms is new. And again, led by Urea, National Rice Research Institute. And our Cambodia project is also focused on rice fallows, but more into conservation ag principles. So what we are doing is similar to what we are doing in Ethiopia. These are home gardens under the mulching and under drip irrigation systems. And for rice, we are also looking at the continuous cover using some of the cover crops. And then Manny has done quite a bit of work on that area. And we are trying to produce indigenous vegetables here so that they have high market value. And then also these indigenous vegetables are much more nutritious compared to the standard tomatoes and peppers. So it provides diet diversity to the farmers. And then another thing which we are looking at is this project is led by Penn State by Ricky Bates in collaboration with Royal University of Agriculture. So in addition to those rice-based vegetable systems, we are also looking at perennial vegetables as a fencing to your land, especially in your cropping lands. Oftentimes the fringes or the borders of the land is not efficiently utilized. So we're looking at some perennial vegetables and using the live fences and on. So this is a live fence. This is Acacia pinnata, and then these leaves are very high in vitamin A. So and it could be consumed for the humans. So that's one way. Another area where Penn State is working is on wild gardens. So if you have a diverse crops from trees to shrubs to runners to small plants, all providing different source of nutrients or nutritionally valuable vegetables. So those are some of the things which we are working on. And now there's a couple more slides which is focused on, as I mentioned, soil fertility has been a big issue. And then this is a research which is done by Prasad and the National Crop Research Institute for the Semi-Arid Tropics in collaboration with the NAR system. This is called Zai system, Zai, and this is to improve soil fertility and water management. So what they do is they make these pits, Zai pits, and then in the pits you put some compost, and then also you put a little amount of micro-dosing of fertilizer. So it's one way of precision agriculture for farmers. So you are applying very little amount of inorganic fertilizer with compost. So those pits also conserve the water and then provide the nutrients. So and we have seen pretty much 200% increase in yield for majority of the grain crops. And then as a part of the integrated nutrient management, the IFDC and the National Fertilizer Development Center also working on the concept of urea replacement. And most of you are probably aware of that, especially because of a lot of rice production here. So instead of broadcasting your urea, you apply deep into the soil so that your losses are low. So those are all very simple things which can have significant impact. And in terms of integrated pest management, when the pests and diseases are very often found in these regions, and then you really have to have a good crop rotation systems. But here is a technology which is developed by ICPA, which is International Center for Insect Physiology and Ecology, housed in Kenya. So what they call it is a push and pull system. So there is different crops grown in combination, where one crop is pushing or repelling the insects, and the other crop is attracting them, so that so that you can have an effective control, and it is not affecting your primary crop. So this is a main crop is a maize, and then you have this trap crops. The trap crops could be there are several types of trap crops, but in this case it's desmodium intercrop legumes. So they produce volatiles which will repel the insects, and the napier grass borders they produce also volatiles which attract them out, especially the stem borer. So that's a push and pull technology, and there's a lot of interest in this technology, and there's some of the other species include brachiaria grass, primarily for insect control. So that's another nice technology. And the last one is the agroforestry systems. And this is a typical landscape in most of the sub-Saharan Africa which you see. And agroforestry system, of course you're aware of the World Agroforestry Center, or previously known as ICRAF, which they have developed multi-storied croppings, all the way from perennial plants to the annual ones. But I specifically wanted to show you this one, because this is a typical landscape, and these are Fidelbia albida trees. And as you see, this is a summertime. This is the time of the cropping season. So you see all the crops are green and nice, but these trees are really, they don't have any leaves. But if you go back in the summertime, this will be a full of green leaves. The trees are full of green leaves. So it's a reverse phenology, meaning that these trees do not compete with the annual crops during the cropping season, whereas in the off season, when it is too dry and too hot, these trees have the green leaves, and the cattle come and sit under these trees, and then they supply the nutrients. And then the roots also pull up the water and then redistribute the water to the top soil. So that's available for the annual crops. It's a really a nice nice component which you often see in these landscapes. So the Fidelbia albida trees, and then, as I said, hydraulic lift, they shred the leaves, and then they provide the green manure to the crops, and then animal manure is also available. Richard Dick from Ohio State University has done quite a bit of work on that. So finally, the Mechanization Construction, as I said, we are working on multiple things. Here's just an example of hand-operated water lifting technology, and this is a fertilizer spreader and a sprayer mounted on back of the motorcycle, and thresher, and then harvester, transplanters, the rice nursery transplanters, and this is an improved yoke for animal power. So, and this is a yoke which is designed so that it's not too heavy or too cumbersome for the cattle which is pulling that machinery. So animal welfare is equally important in these regions, and that Mechanization Consortium is led by University of Illinois. So I hope I gave you some specific examples from different agroecologies to show how sustainable intensification can improve food and nutritional security of the smallholder families. So in conclusion, hopefully I've convinced you that although there is a big challenge of improving food production by 60% by 2050, but there are several opportunities as well because of the big yield gaps for major cereal crops and legumes, and also there is a tremendous opportunities to effectively provide the nutrients to the crops, and also minimizing the waste and food loss and food waste. And sustainable intensification provides holistic and local solutions to address the global challenges. And then engagement of farmers and youth, particularly women, and value chain partners and private sector is critical. And this integration of private sector and engagement with the farmers and youth and women should happen at the beginning of the project, not at the end of the project, so that we get the buy-in from all of these people to ensure that the technologies which we are providing are adopted by the farmers. And then understanding the social networks and barriers of adoption of technologies are equally important, if not more, than developing technologies. We have tremendous amount of technologies, but the adoption has been very poor. So we really don't have to develop more technologies, especially those which are similar to those which are already being developed. So we need to understand the barriers of adoption. And then not only understand the barriers of adoption, but also create an enabling environment in terms of economics, the social, political, knowledge sharing platforms and new communication technologies, so that these technologies are adopted and scaled at a level to which it can have impacts on food and nutritional security. And then better linkages between agriculture, nutrition and health should be articulated to all audience, particularly civic societies, policymakers and donors. This is the only way we can bring more funding to agriculture. Right now people think agriculture is risky, agriculture is labor, agriculture is dirt, but we really need to show them that agriculture is food, agriculture is business, agriculture is nutrition, and then we need to be talking about these to policymakers and donors. And then transdisciplinary research and collaboration is critical. These grand challenges are complex and they're wicked problems, so they cannot be addressed by one single discipline. So we need a multidisciplinary students and researchers who are addressing these issues. And of course, human resources and institutional capacity should be enhanced to make sure the programs are more sustainable, particularly in the countries which are currently food insecure. And then finally, I close by saying that it's a continuum, right? We really need to take care of soils. Soils are very key. I think our lab really has this philosophy of better soils or improved soil health will lead to improved plant health, and having healthy soils and healthy plants will lead to healthy animals, and which can all finally lead to healthy human beings. So it's a healthy soil, healthy plants, healthy animals, healthy humans. So that's the really philosophy of our lab. And with that I'll close. And then these are the website where most of the information is available if you want to get more details. And don't hesitate to send me an email if you have any specific interest in any of those topics. I know I rushed through because we were running short of time, especially we came 30 minutes late, but hope there is a little bit of time for interaction and questions. Thank you again for giving me the opportunity to come and talk to you guys. Thanks.